Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. This is lesson 17, area of a circle. We're going to start off with a classwork exercise, actually 3 of them. We're going to solve problems below individually to explain your solution. So the first one says, find the radius of a circle. If its circumference is 37.68 inches, use pi equals 3.14. So now try this, pause the video, come back and see how you did. So here we go. So it says circumference here, so I'm going to use the circumference formula, which is C equals 2 pi r, or C equals pi times diameter d. Then I look at the question and it says find the radius. So we're using radius here, and that's r. So I'm not going to use the pi diameter formula. If it said find the diameter, then I'd use this formula. So now they're giving us the circumference of 37.68. So I write 37.68 in place of c, that's substitution, times 2 times pi times r. We're trying to find r, but we want to use pi as 3.14, so I'm going to put 3.14 here times r. Now we're just simplifying. 37.68 equals 6.28 r. Divide by 6.28. Divide by 6.28. And that will cancel these. And that will give me r equals, and it's 37.68 divided by 6.28. Okay, so here's my calculator. 37.68 divided by 6.28 equals 6. So the answer is radius of 6. Okay? So there's our answer. Let me just move that up a little bit. I'll put it over here. And there's one thing I'm missing, and that is your unit of measure. So let's just write that. So the radius equals 6 inches. Okay, number 2. It says to determine the area of the rectangle below. Name 2 ways you can use. Name 2 ways that can be used to find the area of the rectangle. Okay, one way. First of all, pause the video, see if you can do these, and then come back and I'll show you the 2 ways. Okay. Process 1. Formula is area equals length times width. Area equals length times width, which is 6 times 4. So the area equals 24 centimeters squared. Process 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 centimeters squared. Okay? And to explain that, you would just say simply count each square since it is a square unit, 1 centimeter by 1 centimeter. We can simply just count the squares. Okay, number 3, find the length of a rectangle if the area is 27 centimeters squared and the width is 3 centimeters. Try this, pause the video, come back when you're done. Okay, here we go. I am going to try to be really neat here in this video. So I'm going to bring my ruler down, which I'm trying to teach you proper procedures in doing a math problem. Okay, try to be as neat as possible. And what I am doing here is I am drawing a rectangle. It's always a good idea to have a diagram when doing problems involving shapes. Okay, so here's my rectangle. Just corners a little bit, that's good enough. Okay, so there's my rectangle. It says find the length. I want that. If the area is 27 centimeters squared and the width is 3 centimeters. So area equals length times width. In this case, we know the area, so we put that in place of A. 27 is A. The length we still don't know, and the width is 3. So this is multiplication. So we simply do the inverse operation to get rid of the 3's, and we get the length to equal 27 divided by 3, which is 9. So my answer is 9 centimeters. Okay? Exploratory challenge. This is a really neat way to think about a circle. So what they're saying is to find the formula for the area of a circle. You cut a circle into 16 equal pieces. So this is 8 shaded and 8 not shaded, forming a circle. So it's like a pie being cut into 8 pieces. And what they are doing now is cutting them out and laying them next to each other. So this is an approximate straight edge, even though they are slightly arched. They're arcs. It's close to being a straight edge. And then if you do the same thing with the unshaded and slide them over a little and up, they will go together tightly and there's no spaces. And then this side here is straight as well, so that forms a rectangle. The radius is your height, and half of the circumference, this is half and this is the other half of the circumference is your length. Okay, so now it says the circumference is 2 pi r where the radius is r. Therefore, half of the circumference is pi r. So half of 2 pi r is pi r. So that's my length. And the radius was r. So now we have pi r times r. So it says, what is the area of the rectangle using side lengths above? So you would say area equals length times width. Area equals pi r times r, which equals pi r squared. Then it says, are the areas of the rectangle and the circle the same? And the answer is yes. Remember though, this is just an approximation because this is really a rectangle with these little arcs. But it's close enough to explain where the area of the circle comes from and how it can be represented as a rectangle. Okay. Now we are given, it says, if the area of the rectangle shaped and the circle are the same, what is the area of the circle? Okay, I've already answered that question. It was pi r squared. So the area of the rectangle is pi r squared. The area of the circle is pi r squared. Okay, so they're both A equals pi r squared. So I'll just write that there. Alright, so example 1. Use the shaded square centimeter units to approximate the area of the circle. What is, so we want to approximate the area. So they're telling us that these are 1 by 1 centimeter squares. And they want us to use this shaded square centimeter units to approximate the area of the entire circle. Okay, so what I would do is say, okay, well this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll write the total up here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The total up here. Now notice I'm outside a little bit shaded, but there's pieces down below that aren't shaded. So the little pieces that we're missing are going to be, some are sticking out, some are short. If you flip them over, they would actually fit in here pretty close. Remember, this is an approximation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I left a little there that would offset these pieces here. So now I have 9. So I have 10 and 10 and 10 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll write them over here. There's no room. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That one stuck out a little bit here. It's outside the circle, but there's a piece here that was inside that we didn't count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3. If I add all of these up, 3 plus 5 is 8, 15, 23, 31, 49, carry the 4, 5, 6, 7. So I'm approximating the area of the circle to be 79 centimeters. Okay, there's my approximation. I simply counted the squares. Now that is just a quarter, so I'm not done. I just realized this. They asked for the area of the circle, and this is only 1/4 of the circle. So if I multiply that 4 by 4, because there's 4 quarters to this circle, then the area would equal 316 centimeters squared. This is the area of the quarter circle. Okay, this quarter piece times 4. So what is the radius of the circle? Well, that was the first row I counted up from here to here. It was 10. So I'd say R equals 10 centimeters. And then it says, what would be a quicker method of determining the area of the circle other than counting all of the squares in the entire circle? Using the formula. Okay, so area equals pi r squared. And area equals pi times my radius, which is 10 squared. So the area equals 10 squared is 100 pi. Well, pi is 3.14 approximately because it's rounded. So if I take 3.14, multiply it by 100, that moves the decimal 2 places to the right, and it leaves me with the area of approximately 314 centimeters squared. So if you look up at our estimate by counting the squares, multiplying by 4, we're only off by 2 square centimeters, which is pretty close. Now it says use the diagram. How many squares were used to cover 1/4 of the circle? And I've already counted that. That's right here. Okay, so I would say 79 squares. What is the area of the entire circle? The area of the entire circle is 314 centimeters. Okay. Example 2. A sprinkler rotates in a circular pattern and sprays water over a distance of 12 feet. Okay, so it's a diagram. So I'm going to grab my compass. I'm going to draw a circle. Okay, so here's my circle. Actually, let me do that. I need to put a dot in the center. You know where my center was. Now I can get rid of this. Okay, so there's my circle. Bring this down. And I want to draw a radius. So here's our sprinkler, and it shoots a distance of 12. Okay, so there's my radius here of 12. I'm going to mark it R and 12. Okay. And it's feet, so I should have my unit of measurement. So our radius equals 12 feet. So there we go. We should always draw a diagram of what we're working with. And it says it right there. Draw a diagram to assist you in solving this problem. What does the distance of 12 feet represent in this problem? And I would say in a complete sentence, the distance of 12 feet represents the radius. Just to save time, I'm not going to write all that again. The distance of 12 feet represents the radius. Okay. So it says, what is the area of the circular region covered by the sprinkler? What area is this covering if I put that in the center of a garden? What information is needed to solve the problem? The formula for area. So the formula for area and the radius. That is what is needed to solve this problem. So now that we know that the area equals pi r squared and we know the radius is 12, we can find the area by saying a equals pi times 12 squared. 12 squared is 144 times pi. And then go back up, just say what to use. Sprinkler rotates. What is the area of the circular region covered by the sprinkler? Express your answer to the nearest quarter foot. So I will use my calculator, and I'll use 144. And this calculator has a pi symbol, so if I hit the second button and then the caret symbol, now I have 144 pi. I hit enter, and it tells me 452.389. Nearest square foot, 0.38 is less than 0.5, so I'd round to 452, which equals 452 feet squared. Okay. Example 3. Suzanne is making a circular table out of a square piece of wood. The radius of the circle that she is cutting is 3 feet. So draw a circle. I'm going to save time here by bringing this circle down here and bringing down the radius. Like that. I'll just use this circle here so I don't have to bring the compass out. Okay, Suzanne, okay, so now it says the radius of the circle that she is cutting is 3 feet. 3 feet. Suzanne is cutting a circular table out of a square piece of wood. So if I came up here and over like this is what they're talking about. It's a square piece of wood that is this circle's getting cut out of. The radius of the circle is 3 feet. How much waste? So what is getting wasted is the piece that's cut off, which is right here. Okay, so these pieces are waste. So if you're cutting a round table out of a square piece of wood, these little pieces here are going to get wasted. So how do we find the area of something that's an arc and then it looks like a triangle with one side pushed in? There's no formula for that, but what we can do is find the area of the complete square, which is length times width, and then the area of the circle. I'll just put a little circle down here with a dot in it, and I'll put an S here for square. So the area of the square is length times width. The area of a circle is pi r squared. So we're going to take the whole thing, the area of the circle, and subtract the area, area of the square, subtract the area of the circle to get the other piece. Okay? Alright, so the area of the square is length times width, which equals, now if this is 3 and I come straight down here, then from here to here is 3. And all radii are the same, so if I came out over here, this is 3. So that makes this segment 3. So the total side is 6. And squares have equal lengths and widths, so 6 times 6. So the area of the square equals 36 feet squared. I said circle again. The area of the square equals 36 feet squared. Okay, now we have to find the area of the circle, which is pi times radius squared. So the area of the circle equals 9 pi. And it says nearest square foot. So I'm going to put 9 pi in my calculator. And it's 28.27. 28.274. So the area equals 20. Area of this is 28.274. I'll just do 27. Okay, so now we have area of the circle, area of the square. I keep saying circle because of the S. Area of the square and the area of the circle. Area of the square is 36 minus 28.27, and I'm going to get my answer. Now, the real important concept in math is never round your steps. Always wait until the very end and then round. If you round the earlier you round in a problem, the more you're going to be off. Because if I rounded this to 28 and then subtracted it from 36, then my precision goes away. So I'm going to just simply subtract 36 minus this answer. So I can say 36 minus that prior answer, and it's going to give me 7.273. 7.73, and that's the area of the waist. So I should write this up here. Area of waist equals area of square minus area of circle. So the area of the waist is 7.73. Now round to the nearest square foot, we'll round up. So the area of the waist is approximately 8 feet. What information was needed to solve this problem? The area of a square, length times width, the area of a circle, pi r squared. I need to know the radius, and from that radius I can find the length and the width, and then to know that we have to subtract one from the other. So there's a lot of information in that problem. So what information do we need to determine the area of the square and the circle? Well, we need the area of the square, we need the area of the circle, and how will we determine the waist? Area of square. So I'd say area of waist equals area of square minus area of circle. Does your solution answer the problem as stated? And the answer is yes. We got 8 square feet of waist. Okay, exercise 4 through 6. Try these on your own. Pause the video, see how you do. When you come back, check the answers with me. The circle has a radius of 2 centimeters. Okay, circle. So I'm going to draw a circle. Put it over here. Okay. This is my radius, and it's 2 cm, 2 centimeters. Area of a circle has a radius of 2 centimeters. Find the exact area of the circular region. When it says exact, that means do not round, and that means to leave it in pi form. The exact means pi. So I would write A equals P pi r squared. A equals pi times the radius, which is 2 squared. So A equals 4 pi centimeters squared. And that is the exact answer. Then it says find the approximate area using 3.14 to approximate pi. Well, there's no need to redo the whole problem again. I can just say now that the area equals 4 times 3.14. All I did was substitute in 3.14 for pi into my answer. So 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 is 5. 4 times 3 is 12, 2 decimal places, and that is centimeters squared. Okay, now it says a circle has a radius of 7 centimeters. So I'll just use this circle again, and what they're saying is this is 7 centimeters. Find the exact area of the circle. So that means use pi. Use pi. So A equals pi r squared. A equals pi times the radius, which is 7 squared. 7 squared is 49 pi. Use your unit of measurement of centimeters. It's area, so it's squared. The area equals 49 pi centimeters. Okay. Now it's saying find the approximate area using 22/7. So we're going to just take that last answer, 49 pi centimeters squared. Substitute in 22/7 for pi. And when I do that, think of 49 over 1. The 7 will go into 49 7 times. 7 times 2 is 14, carry the 1. 7 times 2 is 14, plus 1 is 15 centimeters squared. Okay, circumference equals, now what do we know here? Do we know radius or do we know diameter? So go back again. We were told the radius was 7 centimeters, so we have circumference equals 2 pi r, and r equals 7 centimeters. So it's circumference equals 2 times pi times 7, which circumference equals 14 pi centimeters squared. There's the circumference. It did not say to approximate. It did not say to use pi. It did not say exact. Any answer would have been acceptable here. You also could have multiplied 14 times 3.14 or 14 times that 22/7, which is what I would use because the 7 would cancel 14 and it'd be 44. So if you did that, you should have gotten 44 centimeters squared. All right, last question. Joan determined that the area of a circle below is 400 pi centimeters squared. Melinda says that Joan's solution is incorrect. She believes the area is 100 pi centimeters squared. Who's correct and why? So what we need to do is do the problem correctly and see which answer matches. Area equals, what are we doing? Circumference. Determine the area. Pi r squared. So area equals pi times the radius. Well, this is a diameter, so the radius is only half of that, which is 10. Be careful with that. So the area equals 100 pi centimeters squared. So who is correct? Melinda. Okay, and I'm just going to say the answer rather than write it, but it says who is correct and why. And you would say because the radius is half of the diameter, which is 10. 10 squared is 100 times pi. Where Joan thought the radius was 20, so she said 20 squared is 400. So Joan actually squared the diameter instead of the radius. Okay. Here's relevant vocabulary. Circular region or disk. Given a point C in a plane and a number r greater than 0, the circular region or disk with center C and radius r is a set of all points in the plane whose distance from the point C is less than or equal to the radius. The boundary of a disk is a circle. The area of a circle refers to the area of the disk defined by a circle. So circular region. I'll explain that more in class. That's the end of the problem set, or end of the lesson. go do your problem set.